Hi everyone, this is Benjamin Ahmad Nia, the first and corresponding author of the paper entitled An Effective Optimization Method for Neural Machine Translation, the Case of English-Persian Bilingually Low Resource Scenario. This paper has been written by me and my supervisor, Dr. Raul Aranovich at University of California, Davis, to be appeared in the 7th International Workshop on Asian Translation Proceedings. Let's start by introduction. As you know, employing neural networks in machine translation significantly reduces the time consuming and laborious operation steps such as word alignment, phrase extraction, feature selection, etc. Although the quality of neural machine translation models heavily depends on the quantity as well as the quality of the training data set, considering the low resource condition, the impact of neural machine translation is still not as much as the statistical machine translation. Neural machine translation has recently achieved great success, which surpasses statistical machine translation in many high resource language pairs, and it has become the machine translation approach. In this paper, we compare the impact of multiple neural network optimization algorithms under with respect to the low resource condition, and then we propose an effective optimization method for our case study language pair. The motivation for choosing English and Persian as the case study in this paper is the linguistic differences between these languages, which are from different language families and have significant differences in their properties, may pose a challenge for machine translation. Our results show that the proposed optimization algorithm for English-Persian neural machine translation works well and improves translation results compared to the English-Persian statistical machine translation paradigm. Now let's talk about our methodology. Given a training data set with n bilingual sentences, an attentional training loss function is defined as the conditional log likelihood. The performance of neural machine translation systems is determined by the method of model optimization. Three typical model optimization methods are ADAM, ADA delta, and stochastic gradient descent. ADAM combines the best properties of the ADA-GRAD and RMS prop algorithms to provide an optimization algorithm that can handle sparse gradients and noisy problems. Its main advantage is that after offset correction, the learning rate of each iteration has a certain range, which makes the parameters more stable. Also, different parameters have different adaptive learning rates, which are suitable for large scale datasets and high dimensional parameter space. Ada delta is an extension of Ada grad that reduces its aggressive, monotonically decreasing learning rate instead of accumulating all past squared gradients. Ada delta restricts the window of accumulated past gradients to some fixed size, and its advantage is that the learning rate is adaptive and the experimental results are reasonable. However, the disadvantage is that the convergence speed is slower. And as you know, SGD or stochastic gradient descent is an iterative method for optimizing and objective function, with suitable smoothness properties can be regarded as a stochastic approximation of gradient descent optimization, since it replaces the actual gradient by an estimate thereof. Its advantages is that it's simple to implement, and the experimental results are more stable and reliable under the appropriate learning rate scheduling scheme. And while its disadvantage is that it's difficult to select the appropriate learning rate. Also, it's not bad to know the stochastic gradient descent method calculates the gradient in each iteration of training corpus and then updates the model parameters, which is the most basic optimization method of neural network model. In our paper, this method refers to the mini batch gradient descent, and in the next slide, I will talk about experimental results and experimental framework. Well, for the experiments, we use Tehran English-Persian parallel corpus that contains about 594,000 sentences. We allocated about 550,000 sentences to training step and about 10,000 sentences to validation step, and also about 30,000 sentences to testing step. We employed byte pair encoding, BPE, as an effective way to overcome the unknown word problem in standard neural machine translation. And also in the experiments, we limited the vocabulary size to the most frequent 10,000 tokens and replacing the rest with a special token like U and K, unknown words. We accelerate training by discarding all sentences with more than 30 elements, either byte pair encoding units or actual tokens. Also, the vector dimension of bilingual words is 512. The size of hidden layer is 1024. 1024. The beam size is 10, and the size of mini batch is 80, and the dropout of output layer is set to 0.1. In order to reduce the problem of unlisted words, the size of Persian English dictionaries is set to 20,000 to cover about 95% words. In order to reduce fitting, we set epoch as the maximum number of training rounds to 60, and the evaluation metric of blue is our standard evaluation metric. The following experimental systems have been employed in our experiments: Moses, RNN search, and Mantis. Plus Mantis plus Ada Delta, SGD, and Adam. Moses, as you know, we updated the baseline system on top of Moses as a standard phrase-based statistical machine translation. RNN search is compared with the method using by the paper under the same experimental setting, and also we employed Mantis on top of Dynet as the attentional neural machine translation open source system. Its cycle unit is long short-term memory, LSTM, that in which the default parameter configuration is used. And the last system, Mantis plus Ada Delta or Mantis plus SGD or Mantis plus Adam is used as the optimization method of model parameters for English-Persian neural machine translation. This system represents learning rate decay when the iteration exceeds 40 rounds, and the decay rate is 0.1. Well, as seen in the table, the translation impact of Model 3, Model 4, and Model 8 are lower than statistical machine translation, I mean Model 1, and it shows that English-Persian attention-based neural machine translation is ineffective considering the low resource conditions. Also, the results confirm to the characteristics of the general low resource neural machine translation systems. The results of Model 4, Model 5, Model 6, Model 8, and Model 10 demonstrate that increasing learning rate can extremely improve the English-Persian translation quality, where when the optimization method of SGD and ADAM were employed. However, when the learning rate is too high, the performance of translation system will be reduced. Therefore, it can be seen in the case of low resource conditions, the actual neural machine translation system I'm sorry, is sensitive in various model optimization methods and corresponding learning rate. So, selecting the appropriate model optimization method and learning rate has a great influence on the final translation results. Furthermore, Model 7 has achieved the highest translation impact, which surpasses the statistical machine translation system using Moses and the neural machine translation system using RNN search. It can be found that English-Persian neural machine translation still achieves better translation results by adopting higher learning rates and learning rate scheduling strategies with fewer corpus when choosing appropriate model optimization methods. Also, the figure in this slide shows the convergence curves of different system models. Also, from the learning curve, it can be found that the system using Ada delta optimization method converges slowly, and the corresponding translation effect is the worst. Adam optimization method coverages quickly, and the stochastic gradient descent optimization method uses a large learning rate and achieves the effect of Adam optimization method in about 26 rounds. When we execution learning rate decreases, I mean, the translation performance can further be improved, and ultimately, the best translation impact can be achieved. Well, as a conclusion in this paper, an effective optimization method for bilingually low resource neural machine translation models was applied to English-Persian translation. The investigated optimization method significantly enhances the impact of the English-Persian neural machine translation system and surpasses the statistical approach and the previous similar work which achieves the best translation results. Noting worth that our optimization method not only does not depend on external resources but also it has language independence. And as a future work, we want to investigate other methods of neural machine translation to enhance effects in low resource conditions and the application of this method to other languages. Thanks for your attention, and I'm ready for your questions. Thank you.